All right, so I hope my slides will appear. Yeah. So, yeah, this talk is about Kafka's superpowers for your Jupyter Notebook. So you see a Kafka Superman and, well, a Jupyter Notebook. Yeah, and yeah, that's it. I've already been introduced. So for the agenda, this will be very technical. I hope you're okay with that. We'll first talk about the birth of kafi, which is the tool this is about, then the three paradigms of using it and use cases for it. And yeah, so let me do this. That's the plan, and I hope I will be able to do it in time. So let's see. So what happened when kafi was born? So kafi is Swiss for coffee, so that's why this is a coffee cup. And so what happens if you want to create a topic on Kafka, or you want to list topics, or produce messages, or consume, or anything, and just want to do it quickly without having to code? So the answer is, most of the time, okay, use the command line tools. Use kcat, use the standard Apache Kafka command line tools. And that's what most people still do, right? That's still the state-of-the-art developer experience here. So for example, you want to list topics. Let's do this. I have to type this stuff, and then L for list, and then I get a list of the topics and all other information with kcat. Okay. When I use the standard Kafka command line tools, it's even more typing. So let's do this. Bootstrap server, and then list, right? So this is a lot of typing, and it goes on and on. So when you want to recreate a topic, it's not even possible with kcat, but with the standard tools, it's possible like this. If you want to produce messages, you can do it, like here with kcat, like here with the Kafka console producer. But as you can see, I mean, you don't want to type all this stuff, right? Property, pass, key. So if you want to have keys in the messages, you have to write this. It's, I mean, not really state-of-the-art, is it? And if you want to produce messages, for example, using Avro, JSON schema, protobuf, it gets even hairier, like this, for example. So, yeah, I mean, you can do it, but yeah, this is really not a good developer experience, I think. Yeah, same for consuming. And if you want to search through messages, then you can do a grep, of course, because you're in a shell. That's quite nice, but again, lots of typing. You have to not when you use kcat, you don't have to, or you should not forget the -e option and find out that you need this. Otherwise, you can't grep. So let's try this out. So if I write this, it doesn't even work now. But yeah, anyway, sorry, I was too fast. But yeah, you have to write this -e here, and it's just cumbersome, right? Can't we do any better? That's my question. And that's why I developed this tool. And it's not a real tool, it's not a command line tool, it's actually just a Python library, right? But that makes it extremely powerful. We'll see that in a minute. Okay, so first, if you want to use it, it's a Python module, you have to import it. And then you can do things like this, then you can connect to a cluster. So you will have to have a configuration file. Oh, sorry. You have to first go to the Python interpreter. So you import it, and you create an object with your configuration, and then listing topics is like this. That's listing a topic. Or if you want to create a topic, then you say touch. Or create, you can have multiple ones. Still too nervous. Okay. So that's creating a topic. So you already see it's much less verbose than using these standard command line tools. Okay. Now, what we also can do, we can produce some messages. And that works in a way like you do, you open a file and write to a file in Python. Right, so let's do this, or maybe make it a bit step by step. So you first create a handle on the producer with the topic name, and then you produce some messages. So this will be our data set for today. It's a very complex data set, as you see. But at least it has keys. Okay, and at the end we close the producer. And with kafi, you can also, not just produce messages without a schema, but schemas are no problem. Could be Avro, protobuf, JSON schema, whatever you want. In this example, it's Avro, so we create another topic and put a schema here. That's the, I can even go here, like J. So that's the VS, that's the schema for the value. Let's do it a bit more like this. And then it's the same syntax. You only have to provide the schema to the producer object. So, whoops. So, you see we have this value type, Avro here, and the value schema. That's about it. And then you can do the same as before. Produce, close. And now this is Avro. Right? This is not just JSON. So it's very, very easy to use, and you don't have to write so much stuff. And it goes on. So there will be a lot of things like this now. So we can do, for example, like in kcat, you can do a cat. So that means listing or reading the topic, right? So that's cat. Now I see the messages with all the metadata, the timestamps, offsets, headers. We can also read the Avro topic in this way. Or can we? No, we can't, because we haven't told it that it's Avro. But then it works. Right, so it's like, yeah, very simple, that's the idea. Configuration looks like this, just a very short primer on this. So you basically have a YAML file where you can also have variables, environment variables, and then the upper one is for your local host. The lower one is, for example, if you want to connect to Confluent Cloud. And that's the only thing you have to do, right? Just provide a file with this configuration, and then it's done. Okay, there's now 3 paradigms for using this tool. I already hinted at that. Right? Because so far we didn't see a lot of notebook. You saw the notebook here, but it's not notebook power, right? You'll see soon. So one of the paradigms is using it in a shell, like we did before, right? And with that, you get close to an experience which gives you the same experience like the Kafka command line tools, kcat, but just much more powerful. You can use it because it's a Python library. You can use it in code, right? You can use it to build a microservice, a function in Azure, or a Lambda function in AWS. You can use it to build AI agents. I need to drop this, definitely. Whatever you want, because it's just a library, and you can use it for writing your code. And the third one is, of course, notebooks, and that's what this talk is about now. So we go to the next part, and now it's getting hairier and hairier. So we are doing the use cases for Kafka. And the first one is, that's why I wrote this open source tool, because I wanted to have something more convenient for my day-to-day job, and that's Kafka administration. What we do first is we basically create, we again import it, we didn't have to, but yeah, and create 2 objects. One is my local Kafka cluster running on my laptop, and another one is a basic cluster on Confluent Cloud. Okay. Sorry, no, I'm in this mode. Of course, I'm in a notebook, so let's use notebook power. So now we have connected. What you can do for administration of Kafka is a lot, right? Basically all the Confluent Kafka Python client functionality is wrapped here, but much more anyway. So you can list the brokers of the local object, right? That's my local cluster. I can have a look at the brokers from the Confluent Cloud clusters. That's these. It's 12. I can have a look at the broker config. I can also look at one of the brokers in the Confluent Cloud cluster. That's the config of the broker. If I just want to see one configuration item, for example, because you have Python, you do this, right? That's the message max byte, that's 2 megabytes per message, the default for Confluent Cloud. And yeah, we can also try to set the config, so not just see it, but also set it. Let's do it. So these are all one-liners. That's the idea. One-liners, short and powerful. Of course, in Confluent Cloud, you cannot change this, but here on my local cluster, I can do it. And I change it to 1 megabyte instead of 2, the message size. Okay, consumer groups, the next one. So you can list the consumer groups, of course. There's still some old ones. Let's take the latest one here. So that's just a timestamp, in case you wonder. And then we can look at the group offsets. Oh, it doesn't work. That's not so nice. I have to find the right one. That's it. So that's one of the topics we read before using this cut command. And you can see that for this consumer group here, on this topic, the offset is 3. That's at the end of the topic, because we just had 3 messages. Okay, now, one nice thing, now it gets more interesting, I guess, even more. What we could also do is to use this cross-cluster functionality which Kafi gives you, right? So what if you want to have this consumer offset on another system, like on the Confluent Cloud cluster? And for that, on the Confluent Cloud cluster, what we do is we create the same topic there and produce the same 3 messages on the Confluent Cloud cluster. And then there's some convenient stuff in Kafi which lets you copy the group offsets over, right? Like this. So that means you can, with a one-liner, you can copy group offsets. That's very, very helpful for migration, for debugging, all that stuff. We can also check whether it has worked. And it has worked. Now let's delete the consumer group. So that's all what you can get, really all the functionality you want. What about topics? I mean, groups are not so exciting, maybe. We can do, of course, the same stuff as with brokers. We can do config of topics. We can see it. We can set it. So we can set the retention to unlimited here. So that's that one. We can create a topic. You've seen that before. You can remove a topic. You can also use wildcards here, right? Stars or question marks, like in a shell. That's the idea. You can see the topics and their length. So there's lots of Confluent stuff here. You can see how long the topics are, total length. You can see the partitions and the watermarks. So all that stuff which you need as a Kafka administrator is there, right? You don't need to write your own Kafka client tool or Java tool or Kotlin tool anymore. Okay. Let's skip this. So this is about finding a message in a topic using offsets for times. That's also supported. Yeah, let's be a bit quicker. There's some more functionality which is a bit alluding to shell functions or shell commands. It's head or tail, so you can read from the beginning of the topic, from the end. So that was the first message. The last message ends with a 789. All that stuff. But now again, let's go a bit wilder. So usually if you want to copy a topic to another cluster, it can get very hairy, right? And there should be something easy like a cp command on the shell. And that's what Kafi also gives you. So you can say, okay, let's create a new topic on the Confluent Cloud cluster, and then copy one topic from the local cluster to the Confluent Cloud cluster. That's what this command does. That's just a cp command, basically. So you say from my local cluster, so CL is the local cluster, copy topic T to the Confluent Cloud cluster, and the topic T2. So basically this gives you some kind of a mirror maker functionality, right? If you wait and you don't stop this, like here. Yeah, so let's see this in Confluent Cloud. We can log in already. Because I'm probably out. Ah, it doesn't, no, it does work. Okay. That's the exciting stuff. All the stuff with Confluent Cloud now is not local, so this can all break. So be warned. Okay, let's see. Yeah, so these are the most, you can relax doing this Confluent Cloud interaction. Okay, here. So that was the one we copied. We just copied it over from the local cluster. Right, and it's got the same 3 messages with the helpful information, blah, blah, 1, 2, 3, 4, 5, 6, and so on. Okay. So we can do some more stuff, some more shelly stuff here. We can do a word count, for example, if you know that from the shell. It gives you the words, the bytes, and that stuff. You can even do grep, a bit like in a shell. So you can have a regular expression, like this one here. And then this means I want to grep, I want to find the messages which contain the string 456, a substring. And then it tells you, okay, I found it, and it's this message. Okay, Kafi also fully supports Schema Registry, even more than Confluent Kafka, the Python library, because there's some gaps still. So what you can do, I mean, if you know about this, in Schema Registry there's sets of schemas, and this is called subjects. So you can do a variation of the ls command for subjects, so you can see all the subjects. Again, with wildcards, in this case, it's a bit boring, but yeah. We can get the versions of the subject. There's only one version which we basically implicitly created when we, at the beginning, send out these alpha messages. We can get the latest version, all that stuff, right? And to clean up, we can also remove the subject again. So what we do here is we first list the subject, so then it's still here. We remove it, and then we list again and see that there's no more subjects. But as you know, in Schema Registry, if you do this, then it's only soft deleted. So you can still see it when you list with deleted.isTrue. So let's kill it off completely, because we don't want to spend all that money on Confluent Cloud. Oh, it's my local cluster, but still, you know. Now it's completely gone. Okay, so there's more stuff supported. Also compatibility check and all that stuff. Okay, did I say this? Yeah. Time to close your eyes for a second. Breathe, if it's too much. Now we get to more interesting stuff. Or I close my eyes first, also no. Okay. Simple stream processing. Kafi also offers you this because there's many use cases where it's helpful to have like very, very shallow stream processing capabilities. And it's, again, very, very easy to do. It's by far, it's not about, this is not about like a competitor to Flink or Kafka streams or Python libraries like Bytewax or Quix, Pathway, you name it. So use them if you want to have really complex stream processing. This is very simple stuff. And shameless plug, if you want to read about stream processing, streaming databases, this book is recommended. Sorry. Always the marketing. Anyway, now, what kind of stream processing functionalities do we have here? So the first is, I mean, all these, I mean, if you use Kafka Streams, for example, or the Flink Data Stream API, you will be very familiar if you're a functional programmer, right? So what we can do a for each, for example. That's the simplest one. So for each means you just do some operation without return value on each message. So let's do this. Just print out the key. So we just print out the key now. So that means we go through the topic, And for each message, we do this lambda expression, which essentially gets the key and prints it out. We can do more stuff. We can do a map, for example, which means it's a single message transform in a way, if you know that. Right? So what we do is, for each message, we essentially increase this number, which is in the blah field, by 1,000. So that's this function, this add function here. Whoops. Right, so we access the message which we read. We take the blah value and increase it by 1,000. And that's the command. So you can see here, let me go here again. You can see that these values have increased by 1,000, right? And you can go further. You can also not just return this as a Python object, but you can write out the modified messages, the transformed messages to another Kafka topic, right? So let's do that. And what we do here is we don't only write it out to so we read from a local topic, from a local cluster, and we write it to Confluent Cloud. So you can do any kind of cross-cluster interaction here, right? You just have to juggle around with the variables. So in a sense, here, from the local cluster, do a map of this topic to Confluent Cloud and this topic and use the add function. Okay, let's do this. And then let's already go to Confluent Cloud to see whether it has worked. Network is working, that's cool. So that's the result, hopefully. Let's see. Yeah. So you can see that the result of the map with these messages, which are increased by 1,000, are here on Confluent Cloud. Okay. There's more stuff. There's filter, for example, so you can filter messages. You can also write this out again to another topic somewhere else, for example, on Confluent Cloud. Let's maybe do this. And already go to Confluent Cloud. That's the filter topic. And in this case, we only want to see the messages which have 4, 5, 6 as their value in the blah field. So it should only be 1. Let's see if that's true. Yeah, that's true. So that's the message on Confluent Cloud on the topic. Okay. Here. Continue. So next stream processing function is fold left. That's a bit like reduce in Kafka Streams, for example. So again, we write a function here, which means we, it's the one above. So basically, we just sum up the values, right? So we have an accumulator and access the message which we have read. So we read one message at a time. We have an accumulator in memory. And this accumulator holds the sum, and the command is again like a one-liner, right? So it's fold left from the local cluster, from using topic T, use this sum function in the starting value 0. Right? So that's the sum of the numbers in the topic, in the blah field. You can also use fold left in a way that you write out messages to another topic. That's a bit more involved. So the first line here with the accumulator is the same. And then what we do is we create a new dictionary, a new message, essentially, in memory. We delete this blah field, add a sum field, and the sum field holds the latest sum, which we have accumulated over time. And again, we write it out to Confluent Cloud. That's the fold left one. Okay, like this. Let's see if it comes. Yeah, so what should happen exactly? So you see here in the sum, it's so far. You see that the sum here is the first number of the first message, then that's the bigger sum, that's the final sum here. Right. Okay. Now, if that wasn't enough, we have another thing. We have simple joins, which are a bit inspired by the work from DBSP or the Feldera people. It's really interesting stuff. So with this simple line, you can also do a join, right? So you take, let's again do this on screen. So that means from your local cluster, take this topic, do a join of this topic with the sum topic on Confluent Cloud, which we've just seen, that's T5, and write out the result of the join of two clusters to the local cluster again to another topic. So again, it's cross-cluster, right? In a way, cross-cluster stream processing. Okay. Again, no, just wait. Takes a bit. And it worked. Now let's see the result. So we just do a cat on the result topic. And then you can see that the join has worked. So it was a join driven by the key. You can also write a new, your own function for joining on whatever you want, joining on the value, some field there, some whatever, so you can freely configure this. In this case, it was the simplest form of the join, the default one on the key, like in Kafka Streams. And you see that we have the blah field and the sum field of these two topics joined together. Okay, next thing. I mean, I have to be a bit quicker, I think. What Kafi can also do, you cannot just access the Kafka cluster via the direct Kafka API. You can also go over the REST proxy. Sometimes this is helpful due to network conditions or whatever. So you can create a REST proxy object in the same way as you did a direct Kafka cluster object. And this takes a bit too long. This might be the first glitch here. Ah, shoot. Why the hell? Yeah, maybe we can skip this. Sorry. Connection refused. Okay, one more try. Otherwise it takes too long. Why didn't it start the REST proxy? Okay. Again, time to relax. For you. Okay, so that's the REST proxy now. We should be able to connect. It works. Oh, finally. So this is basically an LS of the topic using the REST proxy, not direct Kafka. And in order to believe that, you can also see the debug information here. So that's the REST requests. And you can basically do the same stuff, the same commands, including all the stream processing if you need this. But you can do this. You can use all the same commands over the REST proxy as well. Right? You can produce in the same way. You can do a cut in the same way. It's the same. Okay, there was a side note. More interesting stuff might be this. More new stuff, more novel stuff. Kafka Backups, because that's something which we needed at my workplace. And for this, I built what I call Kafka emulation, right? For example, sometimes you want to have a snapshot of a topic on your local disk or on S3 or whatever. And again, what you can have is create a new object using a new cluster type, which is this Kafka emulation. It's not a cluster, it's just emulation in a way I will tell you later. So what you can do, what we do here now is we again connect to Confluent Cloud. We set up this local Kafka emulation object. Upsala. We read from this fold-L topic, which I've shown you on Confluent Cloud before. And then again, it's a one-liner to copy, to back up a topic from Confluent Cloud. So let's Confluent Cloud copy this topic to this local Kafka emulation with the same topic name. So it's always the same syntax, right? So this takes a bit, because it's waiting for new messages which will never come. Okay. Oh, and it didn't work. One more time. That's the Confluent Cloud stuff, which can be dangerous to use in a demo. Why is it so slow? I love live demos. Fail, fail. And I can't even stop it. Okay. Neu starten, I won't do this. Ah. Okay, at this part in the demo, yuck. I will do a restart now. Okay. One more try. Class not defined. So if that doesn't work, we do something else. Oh, it worked before, I promise. No, it worked. Okay. Glitchy network. Okay, now we have copied, maybe you've forgotten already, we've copied a topic from Confluent Cloud to our local Kafka emulation. We can also use the same commands like ls or l here. See that it's there, that there's 3 messages on it. We can do cut in the same way. And we can have a look at the consumer groups, which we have created by reading the topic using the cut command. And we can even have a look at the group information, right? And how does this actually work under the covers, right? What kafi does, basically it's very, very simple. So you have a topics directory, you have for each topic some metadata, like this, how many partitions it has, the config. And then you have the data in this partition directory, and that basically is just a list of files which in a way says, okay, on partition 0, from offset 0 to offset 2, and from timestamp here to timestamp there. That's this bunch or this batch of messages, and as you go on, you have more of these batches. That's basically it. For consumer groups, it has its own groups directory. That's my consumer group, which was implicitly created before using this cut command. And that's again just a JSON or dictionary object, right? It tells you the state of the consumer group, yeah, and the offset, most importantly. What I didn't show you were the messages themselves. Come. You see here, yeah, so that's the messages. That's just Python records, one line by another. The important thing is that these records contain all the information, right? Header, key, value, all this stuff, even timestamps. So that means you can copy stuff to your local disk using this format and also copy all the messages back. You will not lose anything. It's a perfect backup. And now you don't have to just use your local disk. You can also use S3 like this. It works in the same way. So I connect to my S3, my local min.io. So still the list of topics is empty. And again, I use my copy command here. And what I do here is to copy this topic from my local Kafka cluster to the S3 cluster emulation, right? So the target S3 cluster is emulation, basically. Yeah, I'm missing stuff because I had to restart the Python notebook. Sorry. Okay. Right. So we just copied it over to S3. It's 3 messages long. We can do a cut on Kafka emulation on S3. That was this command. And let's go to min.io to see if this has worked really. So you see the same structure as on your local disk is also an S3. Okay. We can also do some hairy things. We can copy back, for example, the locally emulated topic from S3 to Kafka or to Confluent Cloud. I mean, this all works. Not time for this now. The last use case is for kafi is, and that was why I chose the name. It's for integrating Kafka in files, right? You've seen this a little bit with this Kafka emulation, which emulates Kafka using files and no cluster at all. Especially for doing backups. You can also use it to go from Kafka to dataframes and back, right? So let's do this. Let's read our topic and put it into a Pandas data frame. So that's the data frame we got from the topic. I mean, the data is, again, a bit simplistic, but yeah. Okay, and we can go back. So we can take a data frame. It has to be in some right format, but for the demo here, the simple one definitely works. We can copy the data frame back to a topic. This is a new topic on our local cluster called topic df, and then or TDF, and then we see that we've now copied the basically the data frame back to a topic. And what got lost on the way is the key. So you can see that this was using this functionality by the key being deleted here. All right. Now, once you have topic to data frame to topic, you can use Pandas, right, on Python. And if you know how powerful this library is, I mean, one of the nice things about Pandas is that it has multi-format support, right? So it supports CSV, you can read it here, Feather, JSON, ORC, Parquet, Excel, well, this is a misspelling, XML. So what we can do is to basically simply building on this functionality. It's not much code. We can actually dump a topic into a Parquet file, right? And because we have the option between local storage, S3 or Azure Blob Storage, we can also say, yeah, let's just copy this topic from our local Kafka cluster to a Parquet file on S3. So that's what this does. Okay, let's have a look where this has ended up. It's here. You can download it and then have a look whether this is really true or I'm just a charlatan telling you something. So we can use Parquet tools, show topic. This. And again, we see the topic in Parquet. In Parquet this time. All right. There's more stuff. I mean, these other formats, for example, you can use it to create an Excel file. So copy me the topic into an Excel file, again on S3. So, doesn't really update. So that's the Excel file. Now, you can see it in Excel. Same data, same topic, and we actually even got it from S3. Okay. And, oh, that's it, thank you already. The next thing is we can go the other way around, of course. I mean, we had data frame to topic, and we can also use this functionality to bring files back to a topic, right? So again, we create a new file here, a new topic here, this time again on Confluent Cloud. So that's called topic from Excel. We create it, that's the touch command. And then we use file to topic, right? So we get this Excel file, which is on S3, so that's the S here. we copy it to, basically to Confluent Cloud into a topic, and that's the topic name. Okay, let's do that. And go to Confluent Cloud already. Here are the topics. I'm relieved that I could do it in time now, even with the glitches. Okay, now this topic has been created from an Excel file in Azure Blob Storage. And to copy it over, you just needed this one-liner here. Right. So that's basically it. We are in time. Thank you. So that's again a Kafka Superman. And yeah, that's one of the things. So you can get kafi on GitHub and PyPy. And this presentation, this notebook to play it through yourself is also available on GitHub, right? Okay, now, thanks. Now for some questions. Yeah, so the question was whether it's only bound to Confluent Cloud. So you can do any flavor. You can also use Red Panda or WarpStream, BuffStream, whatever you want. So this is not tied to anything. I just use Confluent Cloud as an example. So as I said before, you have these config files which allow you to do all kinds of configurations, the same configurations you can do in the Confluent Kafka Python client. So of course, all brands of Kafka are supported.
To connect to the remote cluster, if you want to pass TLS or connect in a SASL way, we need to pass TLS configuration. Is that possible?
Okay, yeah. So I didn't really get the question.
Oh yeah. So when I connect to the remote cluster, like Confluent Cloud or another from the Jupyter Notebooks, how you are showing, right?
Yeah.
So I need to pass a TLS configuration because the listener is secured by TLS certificates.
Aha. I actually haven't tried it, how the certificates work, but as it's using the Python client from Confluent, which supports this, which is also based on the C library, library Kafka from Confluent, this should be supported, even with certificates. But I haven't tried it myself. I just used my local cluster in Confluent Cloud and Red Panda so far. Sorry. So it's based on really the Confluent clients, which should be able to do anything. So that's no problem.
Yeah, one question for me. So how does the stream processing or the limited stream processing behave at scale when you not just have just a few records in the...
Yeah, depends on what you do. If you do the joins with too much stuff, then you need to care for your memory, right? It's not really thought for that. It's really more... you can do a join if you have like a streaming table join, and you have... But if you do a streaming join, it will break, definitely. Yeah, but I think, from what I tried, it's rather efficient. It's, of course, not comparable to any Rust implementation or Java implementation, but I think it's, for smaller use cases where you don't have so much data, it's, I think, doable.
What is the use case of kafi in Confluent Kafka and data streaming?
Please again.
What is the use case of kafi in Confluent Kafka and for data streaming point of view?
Use case. Thing is, it has no particular use case to nail down. That's why it was also so confusing in a way, maybe. But it's mostly useful for debugging, for Kafka administrators. That was one of the parts. For doing backups, for example. For example, creating an Excel file for your boss, these kinds of things. It's more for like people who are using Kafka and for day-to-day work. But also, you can use it to write simple Kafka clients. So if you want to have people who don't have so much coding experience and they don't want to go into all the depth of the configuration, then there's some sensible defaults which help you to really write all this in one-liners. And this can help in a company where you don't have like true Kafka professionals, but you want to have people who just want to read a topic and put it into their database, right? And for that, so it's kind of a convenience tool in a way. Yeah, so you can do it very conveniently. That's maybe the biggest use cases.